your favorite classes of all time ever?
Truly you are.
Really?
I love this class. I
Miss
love it
Ward
to
said
death.
that to almost every class she's taught.
Favorite Booker's better than
I had to.
Favorite Booker's bugs.
Who was smarter, me or Xavier?
No way Xavier did any class.
All right.
He doesn't get one of them.
This is really important. I told you the other day it was. Get out your paper that you're taking your notes on. If you're out of room, get another sheet out. You're ready for number 20. Okay? We are finding the sum of these numbers. Now, first of all, what kind of a sequence is this? Geometric, because we are going down by a half. We're getting multiplied by a half. Now,
Yeah.
it doesn't say, like a lot of times it will say find the sum of the first 10 terms. It doesn't say that. It just says find the sum. We have a formula that finds the sum for an infinite thing. Do you remember what that formula is? I'll give you the formula. You have it memorized, but do you happen to remember it?
No.
A sub 1 over 1 minus r. What does a sub 1 stand for?
That's not free.
3 over 1 minus a half. So that's 3 over a half, which is 6. And that's the answer. Now you have another geometric sum formula, but it looks like this. Why can you not use that one in this problem?
You don't have an
You don't have an end. You don't have an end.
Oh, do you have an
It goes on forever and ever. If you had an end, then that's going to be used. It will say, or the sum of the first 15.
Oh, okay.
I mean, you just plug 15 in for him.
Yes. All right, number 21. From a standard deck of cards, 2 cards are drawn at random. Find, we're gonna skip A, it's a little bit tricky, so don't worry about A. Let's look at B. Find the probability they are both 3s or they're both face cards. Okay. How many cards are we picking? So 52C2 is my bottom, would you agree? And on the top, I want both 3s. So what would that look like? Both 3s.
Four,
C2.
Right, yep.
There are 4 3s, and we are picking 2 of them. Or, so I'm gonna put plus there, I can get 2 face cards.
2C12?
12.
12.
And then we type that in.
That was squishy.
And someone's stealing my things, so please, if you take one, that's great, but please don't steal it. I'm not sure what class it is, but they're coming out listening. All right, I got .0543. Do not worry about A and C. They are tricky because there are cards that overlap. Do you see that? There are black aces, there are black kings, so don't worry about that. We've been kind of rushed, I'm not gonna go through it. But you should be able to do B, 21B. All right, now I've got my pens. I have 4 red, 9 blue, and 7 green. I'm going to pick 3 at random, and I want the probability of doing it. Okay, now, let's do A. All red or all blue. What is my denominator going to be? What? 22C3. Why is it 22C3? 22 pens, and I am picking 3 of them. It's just like a card hand. 52 cards, pick 2. 22 pens, pick 3.
4C3.
4C3. That's all red. Or
Isn't there
all blue.
isn't there only 20 pens?
Oh,
Nice.
wait. Yes, there's only
Good,
20.
Jimmy.
Thank you, Jimmy.
Yeah.
I believe
boy.
Blake,
Boy, red.
20 pens. Thank you, Jimmy.
Don't worry.
What's the price on that right there?
And then what would
That was
all,
crazy.
what would all blue look like?
C3.
9C3? Right? Now, you guys, when you type this in, make sure, if you're gonna type it all in at once, so 4C3 plus 9C3 equals. Let me try this is a plus. Four. All right, so then hit equals, and then divided by. Make sure you hit equals before you divided by. So point 0.077. All right, at least 2 blue. What does that look like? Same pens. I want at least 2 blue. That means I could get,
Oh, 4C2 plus,
no, how many blues are there? 9.
oh,
So
9.
9C2
Plus 11C1.
times 11C1. Because we need, if we're only getting 2 blue, then we have to have one of another color, right? D3. So here's the 2 blue, and here's the 1 that's either red or green. Or we could get all 3 blue. So at least 2 blue means I'm gonna get 2 blue or I'm gonna get 3 blue. And then it's still probability, so it's still divided by. It's
Why'd you do 9C3?
picking 3 pens and they're all blue. Alright, last one I'm gonna type in. Because it takes so long to do. Make sure after you type in all your top, make sure you hit equals and then divide it by. Wow, I got 0.421. Pretty high probability.
Exactly 2 blue.
Exactly 2 blue would just be this right here, wouldn't it?
Yeah, that's what I was thinking.
That's exactly 2 blue. There were a couple of things that I felt like we needed to practice, not really than just 5, so I jotted them down.
I'm just curious.
So you can do these right on this paper.
Mine.
Please take really good notes, guys. You're gonna wish you had if you have them. Please take very careful notes. Yeah, last one.
Yeah. So we'll try and sort of for the finals.
Yeah.
Also, thank you today.
All right, here we go. Number 1. If the first term is 1/5 and the ratio is -2, I'm supposed to find the 13th term. So over here is my list of formulas. This is the one I'm going to use because that is the formula for geometric term. Right?
If it's D.
So 1/5 times -2 to the 12th.
If it was D, it was
Uh-oh, what does this mean?
You gotta do the
This weird
fill, you gotta
notation.
fill it in, but we've got a formula for that.
We got a formula. Now, in order to know the formula, I need to know what kind of sequence I got. So how do I tell? What do I do? Remember?
Just look at that.
I plug in 1. So what will my first number be? I'm not gonna plug them all in, don't worry. But if I plug in 1, I get -2. And if I plug in 2, -5. And let's do one more. Let's plug in 3.
-8, so you're just adding.
So what's happening in this sequence?
Adding -3.
Adding -3.
Yeah.
So this is arithmetic, and my arithmetic sum formula is this one. Now remember, you get the formulas, but they're not labeled. So you'll have to remember that this is the formula that does arithmetic summing, okay? So how many terms do I have? N is how many terms I've got. We're going from 1 to 52. How many is that? 52. So I'm adding up 52 terms. So 52 over 2. This end, this end, this end, they're all the same. So 52 over 2. A sub 1, you already figured out. A sub 1 is -2. And then what goes here? A sub 52, which would be the last term, which we find by plugging in 52. So that is -155. So with a sigma, plugging in this number, whatever it is, gives you your first term, and plugging in that number gives you your last term. So your answer is -4082. That one okay? All right. Number 3, I have an arithmetic sequence. I don't know what the first 2 terms are, but the third one is 13. 4th, 5th, 6th, 7th, 8th, and the 9th one is 37. And it's arithmetic, and I have to add up the first 20. Now, I will be using this formula again, because it's arithmetic, it's whole, and I'm summing, okay? I got some gaps to fill in here though first. What does it mean to be arithmetic?
Just adding a certain.
I keep adding the same number over and over again, right? So I gotta get from here to there, and I'm gonna add the same number over and over again. I'm going from the 3rd to the 9th. So how many times am I gonna add the same number? 6 times. So 6 of those numbers has to get me from 13 to 37, which is a distance of 24. So D is 4. Does that make sense to everybody? Now, that means that to get from here to here, I add 4. Which means to get from here to here, I would subtract 4. And I want to do that because that guy is my first term. And now I can use my formula. So 20 over 2. First term, we just figured out it. Oh, shoot. What goes here? Not 20. The 20th term goes there. Do I know the 20th term?
Oh, yeah.
You gotta figure it out.
No, but I can figure it out because I got a formula for that too. And that one looks like this. So if I want the 20th term, it'll be 5 plus 4 times 19. Does that make sense to everybody? I got 80. Is that good? And then I can type that in. 860. Two more, and then we'll be done. We'll be whatever you want to do. Find the probability of being dealt a 5-card hand with at least one card. Wait a second. I can erase my photos. Yeah. At least one card.
So what you do when there's 0 on the other one?
So it's a 5-card hand. So if we think about this, this is an immense problem, because at least one heart would mean I could have one heart, or 2, or 3, or 4, or 5, right? What is the only thing I don't want? No. So what if we did 1 minus no hearts? Wouldn't that leave me with the leftover? So it's a 5-card hand with no hearts. What is that? What's that look like? No hearts.
48
No. No hearts.
Oh.
39 C5, right? Are there 39 other cards that aren't hearts? Divided by 50. So again, you can do the problem by working out all the scenarios, but that's gonna take forever. This is a lot faster. Does it make sense to everyone?
Yes.
Who said no?
Oh, I think so. You have to subtract
Yeah,
all the
no
hearts.
hearts. There's 13 hearts.
You go from all hearts to no
52
hearts.
Heart deck, 52 minus 13. That's just how cards work.
So I got 70 or 0.77 face off.
I think Rachel's like.
I took them home. Everybody get that?
Almost like I did.
One more on the back.
1 minus 39.
We have a 12-question multiple choice test.
I got negative.
Questions are A, B, C, D, E, so we have 5 options. We want the probability of at least 11 correct. So that means 11 correct or 12 correct. Would you agree with that? 2 separate problems. Let's do 11 correct. 12C11, very good. Why do we start with that? Because there are 12 questions, and we gotta pick 11 of them to get right. Any 11 to get right. The probability of being right is 1/5, and I need 11 of those. The probability of not being right is 4/5, and I need 1 of those. This is 11 right, 1 wrong. So that's gonna be a number. Now I'm gonna add to that 12C12, 12 questions, all 12 correct. And then 1/5 to the 12. If you wanna put 4/5 to the 0, you can, but you don't need that. You can put that in if you want to. 7 times 10 to the negative 7. Okay? Any issues? No issues, all right, you wanna look back at the notes and see if you have any questions, or are you think you're good with that stuff?
Could you just like write some like random questions up on the board and we just solve them together?
I totally can. I totally can.
Good idea, thanks.
Let's do that. We'll practice.
I didn't know if you wanted to spend more time on this, or if you want to do some exam review, but this is fine. Some of this is on the exam, so it will be perfect.
It's 2 birds in 1 stone.
Yep. You like to be efficient, don't you, Joe?
Yep.
All right, so limited problems. I may not write this all out in complete sentences, so you're gonna have to figure out
Look
the,
at 80, I probably think it's 15 on the test.
let's do one of these. Let's say I have, 5 algebra books, and 4 geometry books, and 6 trigonometry books, okay? So these are books. And they're all different. So they're categories, but they're different books, all right? So here we go. The question is, how many ways can I arrange them? How many ways can I arrange them? Period. On a shelf. Here's your first question. All right, the second one is, each kind is together. So I'm still putting them on the shelf, but each kind is together. Third one is, only algebra. Fourth one is, needed algebra on each end. And 5, how many ways to arrange if geometry are identical. All identical to their own kind. Unless we get together. Alright, so take a second. See what you think about those, and then we'll talk about it. But all the problems involve those books, various ways of arranging them. Eric, you see what's in this bill?
Should I go with that?
I guess we could go do it on the board, yeah.
Yeah, you can put it on the board, absolutely.
Let's work together on
Yeah,
that.
let's just talk it out.
I like that.
So the first one would just be,
15 factorial.
Oh, is that what it would be? Wait, no.
The second one will be 15 factorial over 5 factorial.
I knew I was not doing it right.
how'd you do the second one?
Bobby, how'd you do the second one?
I thought it's the same as like if we had a bunch of letters.
I forget. No, you're.
Each kind together, so you'd have 3 kinds together.
So it's 3 factorial times 5 factorial.
Watch
That's how we did it.
I thought it was the same as like if we
If
got
they're
a
all
word.
if they're each tie together, it's three.
Yeah, it'd be the same thing if we have a ward, so it's word.
Yeah, so in that case, it would be 15
It's 15 divided by-
factorial over 5
But yeah, that's what
factorial
it said it first.
over 4 factorial over 2.
Oh, yeah.
Is that wrong?
Yeah, no, that makes sense.
Are you gonna tell us if it's wrong?
Yeah, we'll talk about it. I'm not done with them yet.
Do that, or?
Is that one right? Number two.
I was checking our work.
Is number two right?
Number 2, what do we have?
Did we do it?
Factorial or 5 factorial?
No.
Really?
That's wrong.
Number 2 is not
I
right.
Wait,
swear
wouldn't it
to-
just be 5
Is it
factorial
3
plus
factorial
4
times 5
factorial?
times 6 factorial?
Yeah, I think that's
So-
what it
Wouldn't it
is.
just be 5 factorial plus 4
Stop.
factorial?
Okay, this is great conversation. Each kind has to be kept together. So you've tied a string around your algebra books, your geometry books, and your trig books. How many things are you actually arranging then?
Three.
So start with 3 factorial.
And then you
Three
times it by,
factorial.
and you can arrange that 5.
And then you times it by
Then
five.
you multiply that
By
by
5.
5 factorial, 4 factorial.
It's on my paper.
So, again, we talked about this, and this is the kind of note-taking I want you to make sure you're doing. It's the number of bundles, factorial,
So number 3
and then each bundle,
Yeah,
factorial.
that makes sense. Just,
We
it
just
feels.
multiply all this.
Multiply all those together. All the, a bunch of factorials. So you get all
So
of
3 is
them
11
together.
factorial times.
Okay, now, step aside, so only the algebra together.
Is 11 factorial.
Okay, so,
Times.
tie a string around the algebra books. They function as one. Then you've got 10 other books,
Yeah.
so you're arranging 11. So number 3 starts with 11 factorial, then times 5 factorial.
Is your only time using algebra?
Wouldn't it?
Would it be times just?
Well, why wouldn't you?
You're timesing the group twice.
No,
You're timesing-
because you only multiply by the bundles factorial. How many bundles do you have in number 3? 1. So you multiply by that bundle. The
Yours
other
higher?
books are 3. They're being rearranged every place. You don't need to type those in, it's a setup.
Hey, algebra. I absolutely.
Okay, so here's my bookshelf. Here's my bookshelf. I gotta put an algebra book right here. How many choices do I have? 5. 5. 5 choices. And then all the way down the end, I have 4 choices. So I got an algebra here and an algebra here. How many books are left? 13. How many ways can those 13
13
books
factorial.
13 factorial.
So is it
So it's
5 times
5
13
times
times
4 times 13 factorial. Okay, does that make sense to
That does
everybody?
make sense.
I'm always in.
Alright, the geometry books are identical.
So that makes sense.
This is like the lighter one.
That's divided, right?
That's 15 factorial divided by 4 factorial.
Oh, because they're the exact same, that makes sense.
That's like those support.
Yep, that's like a word. It's like having a 15-letter word before the letters are the same.
What's the last one?
Everything, the books of each kind are together, and everybody is identical. They're all identical to their own kind. So all the algebras are the same, all the geos, all the trigs are the same. So,
That's right.
yep, he's got it. He's got it. That's it. That's it. It's just, it starts out just like number 2, but because they're all identical, we have to turn around and divide by all those things.
And then it's just they
And
cross
it all
out.
cancels out, and we're done. Okay, folks, we okay with that?
Yeah.
All right.
That one was kinda scary.
Another
Wait, you like,
problem.
you leave 5 and 6 after a second? Yep.
I'll write down the next
Why?
one.
Wait, I still don't understand.
Come on.
Number 3, why we multiply by the 5? Like, instead of multiplying by the 1.
Right. Just stands up there. Not even good. Wait, you guys?
I stand back in the
6 because.
I sit in the iPad.
Move.
Alright, quickly while we're finishing up, some of us are
6
finishing up.
because.
How many ways can 10 kids be seated in a circle?
9
Nine.
factorial. Wait, like I guess.
Yeah.
Because if they're all identical, then that's when you do the dividing stuff. You divide by the 5.
That's when it's the same as the word.
And when they're all kept together, then so you bundle each one, so there's 3 of them.
Yeah.
And then you times them by like all the bundles, so times by the algebra, geometry, trigonometry.
Yeah.
And then you just cross all those out.
Yeah.
Because
Yeah.
sure. This word explains that.
You said it, exactly right.
9 factorial.
Alright. Tell me whether this is a permutation or combination, alright? I have 10 kids, I'm gonna pick 2 to take on a camping trip.
And C.
10 C2.
What's the word called?
Permutation.
What are they called?
Wait, we've done that. Oh, wait. Permutation's like if there's a vice president and a
Just
president.
P.
Yeah.
So
Yeah,
if
specific.
if the order mattered, it would have been 10 P. 10 P.
No, 10 feet.
10 P.
Okay, so an example when the order would matter. I have 10 kids, I'm picking a captain and a co-captain.
10 feet.
That's 10 people, they have different jobs. Okay? Alright, one more. We're gonna have a contest. 50 people are gonna enter the contest, and the prizes are 4 $10 bills.
10 feet.
50 C4.
Yeah, 'cause they're all the
Because
same.
everybody's getting a $10 bill. If 50 people enter the contest, and the prizes are a TV, a phone, a radio, and a math book,
That's P.
then that would be 10 for 50 C4. Alright, everybody got that distinction?
Yeah.
Okay.
Or if you're picking like weird.
Yeah,
That's
yeah, literally.
If you're picking a certain thing,
Vice
then it's
president,
P.
president.
If it's just picking
Pick is P.
amount, then it's just.
He is specific.
All right. I have
Vice president.
3, you can write this down. I have 4 red marbles, 5 blue marbles, 6 green marbles.
I forget the last time I saw Marvel.
How many ways, I'm gonna pick 4, alright? How many ways can I get exactly 2 blue? How
So
many
it's,
ways can I get exactly 2 blue?
so it's 15, on the bottom it's 15. 15 seats. Oh, yeah.
Okay, now, be careful.
5.
Did I say what's the probability?
No.
How many ways?
How many ways? So it's just gonna be your numerator. Alright, probability would be 15 C4 on the bottom. Alright, so how many ways can I get exactly 2 blue?
So 5 C2 to start.
5 C.
No,
Whoa!
or
Is that a signal?
11 or 10.
It would be, yeah, it would be 5C2,
Well, 13.
and then it would be
You know, like you don't
13
C2.
C2.
What are
Alright.
they, 10 C2?
Well, you have.
You already have the 2.
You have 15 total, or six.
You've already picked
15
2, so
total,
there's
and you
13
already
more
picked
big
2,
ones.
so there's only 13 more, and then you just need 2 of the other kind.
Yeah.
Yeah.
Is it,
Okay.
is
The
it
question
exactly
was
2 blue?
exactly
Okay.
2
So then
blue.
So then it would be
11. No, 10.
10.
Yeah.
10, 6,
Okay. Okay,
No.
so yes, Eli, we need to change that 13 to a 10. Because if we're gonna be exactly two blue,
Can't get another.
then that means no more blues. You're picking 2 from the 5, and then the other 3 have to come from red and green.
Wait,
Now,
You times
But if it was a probability, would you still put 13 because there are the other blues?
So you times are at these.
I don't know, what do you think?
I think you times them and then you're adding the other way. That you can
Okay,
do,
but there's
right?
no other way, this is it.
Where's your
This
time?
is it. And why is it multiplied? Because you are picking 2 blue and 2 others, right? So that's a multiplier. Right, we struggle with that, whoa. All right, let's, I wish you hadn't erased my marbles. Let's say we have 5 blue, 6 yellow, and 9 orange. Okay? What is the probability that if I pick 5,
Okay.
I will get only 1 orange? I'm gonna pick 5 and get only 1 orange.
Times
11C4.
Much better,
Nice.
much better. Is that all right?
So much better than
Now,
everyone.
what if I'm gonna pick 5, still probability, I'm gonna pick 5, but I want at least 3 blue,
You get 3, 2, or 1.
at least 3, at least,
5
Oh,
C.
so 3, 4.
there we go. So, at least 3 blue means I can get, no, I have to very specifically look at
Do you
all
have to
3
do
cases.
3, 4, and
I
5?
have,
Wellness.
so do 3 blue, what would 3 blue look like?
Yeah.
Wait, there's 5 marbles. So wouldn't you have times 15 C2?
Yeah.
You have to like get the
Right.
rest of
She was,
I just had that.
he just had.
He told me to
Did
erase
he?
that.
Okay, I'm sorry. I just
Yeah.
understood.
I'm surprised on that.
Now that's 3 blue, but I could have 4 blue. What would that look like?
Same, but then you just
Or I could have 5 blue. Now, that's perfect. A little hint, notice how all those denominators are the same? So I would probably just add up all my tops and then divide only 1 time and not type it in all this extra
But
time.
she wouldn't be able to cancel it.
Huh?
You would not cancel it.
You don't want to, you can't get the probability if you cancel out the denominator.
You can't cancel.
She gets the winning, so if you can.
No, you, where you
Remember,
can't get
B's
the
and
probability.
C's, nothing ever cancels, so don't be trying to cancel. Just
You have
type
to
it
work
in
hard
on your
and you still
calculator.
succeed less than.
Okay? All right.
Yeah, exactly. Same situation.
Okay, a freshman
I don't have to work.
has to pick, we're putting together a schedule for a freshman, and he has to have a religion class, an English class, a math class, and a science class, okay? There are 3 religions to choose from. There are 5 Englishes, 4 maths, and 2 sciences. So that's like the curriculum type. So the freshman comes in, he has to pick 1 of each,
Exactly.
exactly 1 of each. So how many ways, how many different schedules could he come up with? He has to-
How many 4-class schedules?
What, listen to Jackson,
You just times them all.
you just
Yeah.
multiply it.
Yeah.
Yep.
So Jackson, which would be.
When we first did these in class, it was how many outfits do I have if I have this many jumpers and this many, same question. Same question. Okay.
Is there like a key to like know like your timing those? Like,
If it's a certain amount of number and it's how many ways you can get it, you just type them all.
And if it's just by one, right? Like if it's
Like if it's like
one
you
size,
have
one shirt.
5 lunch meat like options and 3 cheeses, how many different sandwiches could you make?
Okay, I've got 8 people.
8 people.
And I'm gonna line them up, I'm gonna seat them in a row. But there are these 2 random children who have to sit together. Okay? So I have 8 kids to seat anywhere, but 2 of those have to sit
I
together.
got 7. 7 factorial.
Total groups.
Every time.
Do you treat them as a
Would
group?
it just be
No, I think they're just.
Do you treat them as like a group?
times
Yes,
2
it's like if we
factorial?
tie them together.
It's 7.
It's
It's
2
7 factorial times 2
Times 2.
factorial.
Yeah, it's
Just
7
times-
factorial times 2 factorial.
Because it's a group of 2.
Why is it 7?
Because 7.
Because you have the 6
6
and
like
then the
group
group.
A.
6 and then
That's 7. And then why is it times 2? Because
there's
that
the-
bundle can be arranged,
Either way.
yeah, just like the book. Just like the book. Okay, write this formula down. Formula problem. S sub n equals a sub 1 minus a sub 1 r to the n over 1 minus r. Okay, you are gonna sum this set of numbers. 15, 5, 5/3, dot, dot, dot. And you're gonna find the sum of the first 12. So S sub 12.
So it's 15 minus.
So the R is
The R is divided by.
yes, divided by 3.
Or is it divided by 3, yeah.
Which means it's
1/3.
what?
1/3.
1/3.
Eli top 2. Get rid of R. So plug that in.
No, why is that an 11?
So I thought you might
Now we plug it in. No. The formula is the formula, Eli, don't mess with it. 22.49999 is what I got.
9.
Okay?
Hot dog.
Look at all that.
I told you guys the checkerboard story, right? With
No.
the checkers on the
Oh,
checkerboard.
You have enough to reach the sun or whatever?
Yeah. And it's way past
I
that.
tried it.
Did I tell you the push-up story?
No.
I didn't?
No.
Sure?
I
Okay,
actually don't think she's very
true story. You guys can't imagine this because you only know me this way. But when I first started here, I was 22 years old. Never talked about it. I mean, I had student talk, but that's all. Yeah, I was terrible. It was an awful year. Cried every day. It was terrible. And because I was the only man on the totem pole, I got the classes no one else wanted to teach. And one of my classes, and I'm not exaggerating, I taught in the classroom that now advancements down there where Mrs. Smith is and all that. That was my classroom. And I had 36 kids. 36. Algebra 1, what we now call CP, back then we called it general. And I had all 4 grades in that class. The cathedral graduation requirement at the time was algebra 1 and pre-algebra counting. I mean, you had to have two math classes in algebra,
Oh, yeah, you was
pre-algebra
two
counting.
algebra.
So kids took pre-algebra, algebra 1, and then they were done. Now, not very many kids did that because they were going to college and they needed more, but something. So I had kids in this class who were freshmen, and then I had some kids who were sophomores who'd taken pre-algebra the year before, then I had kids who were juniors and seniors who hadn't yet passed the class. And it was, anyway. So coming from where I came, which is the farm, country school, very traditional, our types of discipline were, for example, if you were chewing gum, the teacher took it over, stuck it on the wall, and you put your nose in it, and you stood there all period with your nose in that wall of gum. Or if you were misbehaving, I would say, Jackson, give me 10 push-ups right now. And I had a kid in this class who was a wrestler, really good wrestler, state wrestler, and he got to the point where he was deliberately getting in trouble so that he could do push-ups. He would do them one-handed, he would do them with his feet up on the shelf. I mean, it was just a joke. I had had it. I mean, I'd had it. It was all. So I called a meeting with the dean of students, his mom, him, and me, and we sat down and I said, here's what's going to happen. Here's our contract. The dean told me I could drop the contract. Here was the contract. You, student, you have to come to school. You're only a sophomore. You have it's law. You got to be in school. But in geometry or in algebra class, you don't have to do any work. You just have to be quiet. You have to be here. You have to be quiet. You're going to get A's. You don't have to take a quiz. You don't have to do anything. Yeah. And they're all looking like, what are you doing? Okay. Now here are yours. That's my deal. That's what I'm going to give you. Here's what you're going to give me. Today after school, you're going to come down to my room and you're going to do 1 push-up. Tomorrow after school, you're going to come back down and do 2. The next day, you're going to do 4. The next day, you're going to do 8. Remember the checkerboard problem, guys? Right? And that was 64 days, but we were already into the 10th to the 17th or something. So it didn't take long, and he could no longer do the push-ups. And then he had to start being a normal human being and doing class work. And he was. He was very good at that. And true story, he still, when I run into him, sometimes I'll run into him in various places, functions, and he calls me Sarge. He still calls me Sarge. But we worked it out.